Hi there, you're watching the Aussie BIM Guru, and today we're going to run through some site modelling techniques that will help you in site modelling. So we're specifically focusing on roads and curbs today, using both Revit and Dynamo to achieve the solution. So basically here is an example of what we're trying to achieve. So this is natively modelled in Revit. I'll just show you an example. So you can see here this is actually all done with a Revit model. There's no imported masses or elements from other programs, so I'm going to show you how to achieve this. So the challenge that people typically find is Revit's not actually very good at site modelling. It's capable, but it involves a lot of advanced techniques. And typically it would involve using other programs and bringing in masses that aren't flexible to change. But there is actually ways to model roads and curbs which will make your site model more flexible to work with and easier for teams to work with. So the goal is that we're going to match roads to a topography in Revit, and then we're going to model line markings, curbs and curb ramps in the model itself that you can see here. So without further ado, we'll actually jump onto the workflow. So the first step is to create roads from a source topography. We'll set up a source DWG for the topography and for the site itself, which will be quite similar to how we typically go through, I guess, a survey process. So I've got a DWG that represents the site as a topography, and then a DWG that represents the context of the site itself. So for people that don't know how to generate a topography using a CAD file, I'll just really quickly demonstrate that. So if you go up to massing and site, topo surface, create from import, select instance, select your site, select all the layers that contain topography related information. And Revit will generate points for the ends of all the lines on those layers, which will let you generate a topography. So the next step from here is actually to divide this site so that the roads represent a single topo surface. So to begin with, the topo surface will cover the entirety of the site, but we want to start splitting the topo surface. So we'll use the split surface tool. So we'll pick the topo surface, and then we start picking basically each borough that we want to split apart from our topo surface. So I'll just take this line, and this line, for example. And if I finish that, you'll see that now my topo surface is divided into one piece and another piece. So basically you need to repeat this X amount of times for each piece of the site until the roads are actually their own piece of the site on their own. So I'll just jump forward to where I've actually set that up. So you'll see here that these are all individual pieces of the site now, and this topo surface represents the actual divided surface that we ended up with. So I've actually modeled a floor as well to the same boundary. A typical workflow people will do here is they'll go modify sub-elements and start adding and lifting points on the road. This is where I prefer to use Dynamo to save time. So I'm just going to open up a script that I've built that does this and sort of quickly show you how the script works as well. In principle, it will achieve what we call a drape function onto the site. So we'll drape the floor onto the site and then lower the topography to suit. So I'll just open up the script. My browser's not currently loading, but that's okay. So the version of Dynamo I'm using is just here for anyone that wants to follow along with the script at home. In principle, what the script does is lets you select what you want to drape, which in this case is the floor or the road. It will collect a sketch of that floor and it will then extrude it upwards, and I'm basically thickening the surface of it outwards so that I can find everything that intersects around the boundary of the road. So I'm not looking at the internal points of the road, just the edges and how they coincide with the topo surface above, which I'll select here. I'll pick that road surface. It's generating points from the topography, and then it's checking whether they intersect. It's booleaning out any points that don't intersect with the boundary of that floor that I'm extruding up in Dynamo. And then it's taking every first item. This is what I use to make things less accurate. So if I want to take only every second point or third point, I can do that. In this case, we want to use all points. And I'm just using a node here with floor slab shaped by points, which I believe is from the Clockwork package, but there's a lot of packages that have this node in there as well. If I run this, which will typically take about a minute, maybe a bit less in most cases, it will. Okay, so you'll see there in Dynamo the graphic representation of all the points that's used, and likewise here in Revit. If I go back to Dynamo, I can probably see how many points it's actually utilized. And you'll see that we've went all the way down to about 750 points, so quite a lot. You can see all the points represented there, but if I tab select this floor, you'll see that it's actually applied them as subpoints as well. So this is where the floor is now matching the road. What I'd do at this point is nominate a thickness for my road floor, in which case I think I've nominated 150 at the moment. That depends on, I guess, the depth of your road base. But what I would do then is edit surface on the road topo surface, select all the points, go in front view, and lower that topo surface by the thickness of the road. That way when you cut through this section, you actually see the road and then the earth under the road itself. So that's pretty much that step done. What I would do now is actually go through and remove a majority of these points and just find the really critical points along the edge of the road to really simplify when I go to add curbs to the road. But that's the first step of this covered. So the next step, beyond that workflow, which I'll just keep up on the screen for a second for people to read at home if they're skipping through. The next step is modeling the curbs themselves, so using a profile and sweeping it around the edge of the roads themselves. So the workflow is quite simple. We need to simplify our roads a little bit. Typically I advise dividing the road into a few pieces to make it more manageable. And then we make profile families for the curb, and we apply them as a model in place sweep, picking the road edges as the reference. And you can also inset the edge of the road if you want. This is if you want your curb to sit lower than your road, which is actually in real life typically how that would go. But for a high level site model, I find it easier for the road to actually match the edge of the topo, which is currently representing the paving, because the curb will sit in from that typically. So if I just open up another demonstration model before I begin my curb modeling, just close Dynamo. So you'll see at the moment, I've actually cleaned up everything quite a lot. You can see I've broken the floor into multiple pieces. So I've divided it. I've applied a road material to it as well, just for later. But at this point, really what we want to do is actually model the curbs. So I'll just go to hidden line mode to make it a bit faster. So typically I advise doing a model in place for each section of the road that you've divided in principle. So we'll just go component, model in place, floors. It's up to you what category you want these to be, but I usually advise making them the same category as the road, which in this case is a floor. You could make them site as well. And we'll just call these, we'll number them based on the quadrant they're in, so this could be curbs 1. And then we need to start placing sweeps and picking path. And in principle, all you really have to do is start picking edges. And you may see some warnings popping up relating to things being off axis. Depending on your site or your survey, this is quite common and typically just a warning that you should ignore. Given it's a site model, we expect quite a lot of warnings to occur. So I've actually modeled up a curved profile earlier. Sometimes you might need to flip it, but in principle that should get swept around. And sometimes you might need to divide the curb and play with the angle of it in some areas, depending on the gradient of your road. You can see here it pretty much coincides, but sometimes this might go down into the road itself, in which case you might want to break this into multiple sweeps. And from there I typically apply these to the edge of each of those quadrants, and then when I'm finished I would go and apply materials to those curbs as well. I think in this case we just used a concrete material somewhere in here. Don't think I've actually loaded it in this version yet, but there will be a concrete material. Oh no, there we go. It's just that one there. And in principle what you'll get when you finish your mass is a concrete curb on a bitumen road in that case. So that's pretty much that workflow. And we'll go on to the next stage, which is to deal with the actual crossings. So what we'll be aiming for is to not only have pedestrian crossings, but road line markings. But the first step we'll cover is how to do curb ramps, which are quite difficult. So I'll just go back a step. So step 3, adding curb ramps. You can see here we're going to use a modifier subpoint on a smaller floor to achieve the curb ramp itself. We're going to locally change the profile of where the curb meets the curb ramp itself, and that will be the outcome. So we'll model the ramp, split the topography so that there's no topo surface over the top of the curb ramp, manually elevate the subpoints, and then modify the curb. So at the moment everything I'm doing is relative to a level called datum. So what I've done in this model is I've created 2 levels. So I started with a ground floor level down here, and I usually call this datum, so this is RL0. I've nominated a level for my site itself. Typically this would be your ground level of what your building might be on this site at 51 meters, but most things I'm doing are relative to datum so that I can input RLs. So I've just copied these curb ramps across here. In principle all they really are is just a edited boundary with a meter at the far end, splaying out on a 45-degree angle, and then overlapping the curb where that will fold down. From there, I've modified their subpoints, and that's basically just to match the height of the curb, to match the height of the topography. And this I had to do a bit of finessing to find the right height, and then I've lowered these down to meet the curb so that we're going to fold our curb downwards. So the only issue after this is obviously the curb overlaps the curb ramp. So what I'll do at this point is I'd edit this, and I'd start basically making copies to achieve one part here, and one part in the middle. So I can take that part out first. And I can probably pull that back to that point. Okay, pull that back a little bit too far by the looks of it. This part's a little bit fiddly, as you can see. So this part, I am still trying to find a better workflow for this part using Dynamo. But I believe it might be too complicated for basic users, so I've avoided that for this reason. I'll just pull this part back here as well. So this would be the two sides of our curb, and then the last part is the infill in the middle. And what I've actually done at this stage is I've built a special profile, which is basically the curb profile without the upstand to meet the curb, so the curb ramp will essentially come down to it. You should usually get some snaps on these. I'm being a little bit rough with how I'm doing this, so I actually need to load in the profile for this bit. At the moment this is just automatically rotated, so I'll just go and load in here. Actually, I'll just open the curb. So I've just made a profile here, curb profile 2. So you'll see it's the same as the standard curb, but just no upstand. So if I load that in, bring that into curbs done. Okay, so again, if I go back, select profile, and I'll pick curb profile 2. Looks like I need to take off a rotation here that's been applied. There we go. And there you go. So you can see that's pretty much a curb in principle. The only issue here is the topography also overlaps. So at this point, you need to go and do a split surface on the topo, and you'd need to pick the curb ramp as the splitting element. You may need to go a little bit further past the edge of the topo, depending on the extent of it. So here I'm just going to go a little bit past it. And you could delete it or lower the topo. I'll just delete it in this case for convenience's sake. And what you end up with is a curb ramp in this case. There you are. So obviously that takes a little bit of time. I've been a little bit inaccurate there. If you're a little bit more accurate, obviously it looks better. This part takes a while, so I won't actually repeat this X amount of times because this would take way too long. But after that point, you'll see that I reach a point where I have the need to actually model line markings instead. So I'll just go back to this stage with crossings. So I need to add line markings and crossings. So to do crossings, I just use split face on the floor, and I paint the crossings using the paint tool, and I use railings for line markings. So I'll show you really quickly just how I've used properties to achieve that. So by default, you'll see the line marking doesn't actually really look like much of a line marking. And that's because I'm using a material to simulate that instead of a surface pattern. So if I go down to site, you can see I've got a line marking material, and I've got a surface pattern applied to that, which is spaced at 600 millimeters. And then I've actually made an appearance asset that is comprised of 600 millimeters of road and 600 millimeters of stripe. And I've surface aligned that pattern using texture alignment. And I've basically just used the paint tool on a split face. So split face is quite simple. You select the face you want to split, in which case I could pick any one of these. I could split this face, for example, and whatever you draw upon that face will get split and is able to be painted with the paint tool. And there you are. So that's how I achieved the line markings. From there, you may find that sometimes your pattern doesn't come in rotated properly by default. As long as you're in a 3D view, you can actually use the align tool on model patterns, even if they're on a very strange angle or a raking surface to be aligned, and that's how you can line up your pattern so that when you go to realistic mode, your pattern will coincide with the direction you want it to face. Obviously the weakness there is the 600mm pattern could be the road or the stripe, which is simply just a matter of offsetting the pattern by one stripe in order for it to align. So quite simple. For the line markings are a little bit more complicated. So for these I've used the railing tool because since 2019 and possibly 2018 you can actually host railings to topo surfaces. So this is where it's important to still maintain that topography below the floor that we had before. That's why we downset it by 150mm. And for the stripes, so I have solid bands and then I also have dashed bands. So solid bands and dashed bands and also stopping lines. So for this one I've basically just modeled a railing with a 150 by 10 rectangular handrail, height of 5, with no balusters. So it's a continuous rail, and then I offset it by 200mm to get it above the road, and it will follow the gradient of the topography, which in most cases will achieve a line that almost hugs the surface of the floor itself, but isn't actually hosted to it. So you can always pick new host, find your topo surface, and that will now sit upon your topo surface with an offset above the road. And then for the dashed one, instead, I've basically set the rail to a air material so that you can't see it when you render it, but you can see it while you're working with it. And then under that, I've used balusters, which are 150 by 1200 long, spaced at 1200 with gaps of 1200 between them, justified from the beginning with no excess fill, broken at each segment end. And in principle, what that gives me is a stop-start appearance with the balusters, which are really basically just very flat balustrades. And that's how you can achieve line markings. The great thing about this is that you can draw them in plan and then host them to the topography after. The stopping line is really just another solid strip there. So that's how I achieve my line markings, which as you can see is quite an effective outcome. In my demonstration model, I haven't actually modeled all the kerb ramps, but if I go over to somewhere where there are kerb ramps, you can see it looks quite complete and it's quite good. You can see from there I've taken topography and actually applied a material to it rather than model the paving as a floor, given this is a site model. So you can see there I've taken a paving material and overridden the topography's material to achieve that, which led to quite an effective looking site. There's obviously some more steps you can take from here. So the model that I'm showing you is actually a more refined site model that I've set up for other tutorials. You can see that I've done a lot more things to the site itself. So I'll really quickly just show you some additional things you can do to improve the quality of your site model, and some other tutorials will cover these as well. So I'll just go to where I've sort of finished it, set up a few views. So that's coming live out of it. So this is the site plan that I've set up. So here I've applied some graphic overrides, some labels, some text. I've done some split surfaces within the park. So that's different to splitting the topo. So I'm using subregions instead, which maintains the integrity of the topography but divides its surface so you can apply different materials to it. So that's quite simple. I've added a lot of what I call doodads or accessories to the model. So these are things like bollards, lighting fixtures, trees, dumpsters. There's also vehicles in here. At the moment they're hidden in this view, but if I go to a 3D view, for example, I'll just go to an axonometric. You'll see that I've added a lot of vehicles, people, things to really spruce up the quality of the model. Lots of people, trucks. Most of what you see here is Autodesk default. The only thing that isn't is some people files, which I've built myself. But I found most of the blocks for these on just standard open source websites. So they're actually very, very linear in nature, but from quite a distance, you really would almost think you're looking at a real person in a render. I've done some other things, like modeled some shrubs in place, added some park benches, just modeled some shrubbery zones here, and I've modeled most of the buildings around the site as just blocks of in-place generic models, just to give the site a little bit more context. And I've also alternated the paving material in some areas where I want it to look like more of a heritage look. And I've got an Autodesk standard sign, some Autodesk standard traffic lights, which I didn't have to make any changes to. So you can see that it's quite a dynamic outcome, but really a lot of that comes down to the kerb and the road modeling to add that level of detail to your site. So hopefully that sort of helps give you an idea of what's possible. And you can do a lot of really effective renders of the site using this as well. So you can see this is just a standard Autodesk Cloud render of how it looks during the day. Obviously not many changes made. And you can also do night renders. If your street lights are set up to cast light, then you can actually do street lighting studies of your site as well, if that's what you're using Revit for. You can see there, that's sort of how I've achieved that. And that's basically been achieved by actually putting a light in the light family. This is a custom one that I've built, so you can see it actually does have a light source with values defined in it with a light distribution map. So that's quite an effective way of using the site model. Otherwise, that's really all I've done to achieve this model, but you can see the outcome is quite dynamic, and you can do things like section perspectives through it to really get a really dynamic look of the site. In terms of graphical settings, I've set some graphics here. So I've set myself to realistic mode with edges off. I've given myself ambient shadows. I've turned on sketchy lines, but in realistic that doesn't do anything. And then lighting, I'm just doing an exterior lighting with a magic balance of numbers that I like to use, and I've added just a gradient background to it, which is quite a dynamic outcome, as you can see, and can really give you some good site study diagrams for your clients or for yourself. As you can see there, that's quite an effective sheet when it's all put together. So in principle, that's everything for this session. If you've got any questions or comments about the workflow or other ideas, let me know. There's obviously a lot of ways you can do this. This is just what I find quite a simple method that most users can do on their own without too much help. So thanks for listening today. And if you like what you see, feel free to follow and subscribe to the channel. And I'll see you next time. Thanks. Bye.